Semi-supervised learning is another technique used in AI, a subset of machine learning techniques that are powering the AI revolution. Semi-supervised learning techniques can be used to develop and fine-tune AI models, like the large language models we are all accustomed to using as chatbots or for research. Semi-supervised learning developed AI models can also recognize images or objects within images, a type of prediction that falls under the category of classification. An AI model developed and fine-tuned using semi-supervised learning can also be used to analyze your music history and then suggest other music artists and albums. Simplistically put, semi-supervised learning is a set of techniques for training, that is, creating AI models. These are either classification prediction models, which label, in other words, classify data, or regression prediction models that calculate data using other data. An example of a regression prediction model might be one that calculates a predicted biological age using health data. What distinguishes semi-supervised learning as a separate category of machine learning algorithms is that it effectively combines the strengths of two other machine learning techniques. The first of these techniques is known as supervised learning, and it's also used to create an AI model that can make predictions. Its strength lies in its use of labeled data. Data is labeled as input and as output. Supervised learning algorithms carry out a process known as model training to generate an AI model. This involves identifying data patterns that lead from input data to output data, and then using loss functions to calculate the difference between the predicted output and the actual output in the training dataset. During this model training, we not only analyze data patterns and measure the accuracy of our model's predictions, but we also constantly improve the accuracy of our predictions by adjusting the weights in the inner formulas and paths of our AI model. The key with supervised learning is that it's guided, in other words, what we call supervised. We have provided data labeled as input and data labeled as output, and the algorithms must find the data patterns from the input data that lead to specific outputs. Semi-supervised learning, the focus of this video, uses labeled datasets similar to supervised learning to guide the training model, but also blends it with another technique known as unsupervised learning, where unlabeled data is used. When training with unsupervised learning, we use unlabeled data, so there's less upfront work and far more data can be used, since no physical data labeling is required to be carried out by a person or team. The algorithms that fall under the category of unsupervised learning also discover many hidden data patterns and relationships within the data, because the training is not guided by labeling done by an individual or a team. With semi-supervised learning, as the name suggests, we employ a hybrid approach that combines elements of supervised and unsupervised learning. We can utilize both labeled data and unlabeled data to train our AI model. At the same time, we can leverage the advantages of both techniques. Labeled datasets marking data as input and marking data as the output we are trying to predict using the input allows us to direct and guide the learning, in other words, guide the training of our AI model. The unlabeled dataset still allows us to access much more data, enabling us to create a prediction engine based on better data generalization and hidden data patterns, and therefore better at prediction, especially with new unseen data. Your next question should be, how does this work? How can we use both labeled and unlabeled data to train an AI model that can make accurate predictions? One approach to semi-supervised learning focuses on automatically labeling the unlabeled data without human effort, an approach known as pseudo-labeling under semi-supervised learning. The first step can be to process the labeled dataset, to learn what we are trying to achieve from the data. Using the insights learnt from step 1, we carry out an automatic step of pseudo-labeling the unlabeled data. This automatic pseudo-labeling of the unlabeled data using insights learned from the labeled data can involve an entire set of specific techniques and algorithms. The idea is that we use various assumption techniques and algorithms to infer labels for the data within the unlabeled dataset. We are using sophisticated mathematics and statistics to imply or predict the labels using both human labeled data and unlabeled data as part of this labeling process. The result is that we end up with all labeled data, which is a combination of the original human labeled data and a large set of pseudo-labeled data, all of which are ready for training the AI model. The underlying algorithm used in this method of semi-supervised learning is actually a supervised learning algorithm, which in this context is referred to as the base learner. It now makes sense to use a supervised learning base learner to generate our AI model, as all our data is labeled. Like with all supervised learning training, during the training of the AI model, we use a method to measure the accuracy of our predictions and adjust the weights within the model so that the overall difference between a prediction and the original label is minimized. Thanks to our supervised learning base learner, this semi-supervised learning approach results in an AI prediction model that can perform either classification-based predictions or regression-based predictions. Another approach to semi-supervised learning is to use a two-stage process to train the AI model instead of trying to label the unlabeled data. Instead, we first pre-process the unlabeled data to create a pre-trained AI model that contains insights from the hidden data patterns in the unlabeled data. We then use a supervised learning algorithm as the base learner to fine-tune and retrain the pre-trained AI model, this time using the human labeled data as the dataset to create the final AI model. We then have an AI model that has been trained using both insights from unlabeled data and labeled data, ready to make predictions. I'll also briefly mention a third semi-supervised approach that feeds both labeled and unlabeled data directly into the algorithm, no pre-processing, no pseudo-labeling, allowing it to learn from both types of data simultaneously. This method, sometimes called hybrid training, leverages techniques such as consistency regularization, graph-based learning, and self-supervised objectives to extract data patterns and improve data generalization, all without manually labeling the unlabeled data. Hopefully you can see how all semi-supervised learning options can provide the advantages of both supervised learning and unsupervised learning by utilizing both labeled and unlabeled datasets through various techniques. Although the unlabeled dataset saves us a lot of effort in terms of creating more labeled data, it still has to be data that's relevant. For instance, if we're training an AI to recognize sunrises and mountains, our labeled data reflects that, but our unlabeled images must still contain those scenes, even if we don't physically label them. We can't, for example, include random pictures of dogs because our semi-supervised learning will then poorly generalize the data for predictions. To visualize the power of using both labeled and unlabeled data as part of semi-supervised learning, a half-moon diagram is commonly used. This diagram depicts how data related to a specific classification is clustered together during AI model training. For example, reusing our cat and dog image example, data that identifies and relates to a cat or dog classification is clustered together to show the data patterns for each. If we only use labeled data during training and ignore the unlabeled data, we create a very simplistic decision boundary. A decision boundary that classifies new, unseen data as either a cat or a dog on each side. Our decision boundary doesn't really reflect the patterns of all the data associated with each classification. Therefore, some data that is nearer to the cat classification data will actually be classified as a dog image and vice versa on the other side of the boundary. This results in an AI model that's poor at predictions. That is not very accurate at classifying objects in an image as either cat or dog. Using semi-supervised learning, like pseudo-labeling unlabeled data, helps the model learn from all available patterns, resulting in a more accurate decision boundary. Hopefully, this reinforces the idea that using both labeled data and unlabeled data with semi-supervised learning produces a better prediction model. Labeled data helps define cats and dogs early on. With pseudo-labeling, we label the rest and uncover hidden patterns and train the model to generalize better for unseen data. This has been Rag Diamond, and thanks for watching this video on what is semi-supervised learning, a video which is part of my AI Basics series. Please remember to like and subscribe. Your support will be greatly appreciated.